A successful long jumper must, therefore, be a fast sprinter, have strong legs for jumping, and be sufficiently coordinated to perform a moderately complex takeoff, flight, and landing maneuvers. The athlete sprints down a runway, jumps up from a wooden takeoff board, and flies through the air before landing in a pit of sand. During takeoff, the athlete attempts to generate a large vertical velocity while minimizing any loss of horizontal velocity, and in the flight phase, the athlete must control the forward rotation that is produced at takeoff and place their body in a suitable position for landing. During the landing, the athlete should pass forward of the mark made by their feet, without sitting back or otherwise decreasing the distance of the jump. The biomechanical principles behind the successful execution of the run-up, takeoff, flight, and landing phases of the jump are explained. The effects of change in a run-up velocity on the athlete's takeoff techniques are also examined, as there are design principles of long jump shoes and techniques used by disabled athletes. The run-up phase is crucial in long jumping. It is possible to produce a good performance without a fast and accurate run-up. The three main tasks of the athlete during the run-up are: accelerate to the near maximum speed, lower the body during the final few steps and bring it into a position for takeoff, and place the takeoff foot accurately on the takeoff board. It is well known that takeoff angles in the long jump are substantially less than 45 degrees angle. That is usually proposed as the optimum for a projectile in free flight. The notion that the optimum takeoff angle is 45 degrees is based on an assumption that the takeoff velocity is constant for all choices of takeoff angles. While comparing Paula jumping against a professional jumper, we can see that first of all, the velocity that Paula gets is not enough for her to be able to jump more than the professional jumper. Although we haven't had a lot of practice, the technique that Paula used is a good technique because she is running with her potentially most velocity, and then she's jumping with the left foot, and she's getting all her weight and the 45 degrees angle to jump as high as possible. The difference towards the end of the flight phase that the athlete prepares for landing by lifting their legs up and extending them in front of their body. The goal of the landing is to create the greatest possible horizontal distance between the takeoff and the line and the mark made by the heels in the sand. The landing technique should not result in the athlete falling backwards into the pit or otherwise producing a mark that is closer to the takeoff board than that made by the heels. To achieve maximum distance in the long jump of the athlete, it will be balanced between three components: speed, technique, and strength. In Paula's jump, we can see the speed because she's getting all the speed that her body is able to produce. The technique, that is putting all her body in 45 degrees. And the strength, because she's jumping with the leg muscle that is making her jump even higher and more distance from the takeoff board. The takeoff speed of a male elite long jumper is about 10.5 meters per second in a run-through. That means takeoff angle of 0 degrees, and 3.5 meters per second for a vertical jump. This decrease in speed means that the optimum angle of takeoff is well below by 45 degrees. We're able to run forward because we apply a backwards force against the ground. Newton's law helped to explain the relationship between forces and their impact on the individual joints, as well known as the total body in motion. Newton's first law of inertia states that the body remains at rest or in motion except when compelled by an external force and changing state. After comparing to a pro, I would give Paula an 8 out of 10 because she did many hand positions and leg positions that were a good respect to the long jump terms. She was able to raise her hands and put all the body weight in order to get the highest distance she could.